So we've heard a lot about today about sync and replication and CRDTs. We're going to talk about authorization. So user-controlled authorization networks let you control your stuff. In every UCAN talk, you have to have a UCAN pun in the name, so you can control your stuff. Local first authority without boundaries. My name is Zelenka. You can find me most places on the internet as Xpeed. And I created, or started at least, the UCAN project as part of what we pitched at the time as essentially a Rails for local first. We didn't have the term local first 5 years ago, but trying to build the entire stack: auth, data, compute, effects, the whole thing. And a bunch of other people saw this and said, hey, we don't really have a truly local first, peer-to-peer way of doing auth. And they picked it up and they found a bunch of use cases that we had never thought about and extended it in ways that were really interesting. Unfortunately, I only have 10 minutes, so we're only going to be able to talk about a few of them today. I also run a distributed systems reading group online. If anybody's interested, you can sign up there. So the first thing that we did when we were looking at this problem is, we have a web background. And we thought, you have a data layer, something like Postgres. Then you have compute on top of that, like a web server. And then above that, you put your auth plugin. And that failed miserably several times in this local first context, right? Because everything has to be static. And we found actually auth has to live at the bottom of the stack. In our case, in everything we did, it was actually even below data. So this is both for encryption at rest and for doing mutation control as well. So there's two, broadly speaking, there's two schools of thought for auth. The first one, and probably more familiar because it shipped with Unix starting, in the 70s. So just as a quick review, you have a user, they want to access some resource. So this is a server or a CRDT or something. And they make a request, and they're stopped by some process. And this basically acts like a bouncer. And it says, show me your ID. And I'm going to compare that to my list. And I'm going to check that your request says that you're allowed to do these things. And if so, if you're on the VIP list, you're allowed to send that through. And in a cloud setting, this makes a lot of sense. You can run a auth server and abstract that away from all the other parts. Turns out, though, that this has a few problems. First, you have to sync this list around. Which, okay, great, we're good at sync now. It doesn't compose well between different rules. You can't fork them and have them join back together again. This process can be buggy or malicious. You can have an admin who just adds people or removes people from the list or adjusts their permissions, or somebody can break into your server. And it's outside of the scope of the basic design, how you actually add permissions, or even what the model for the permission should be. So this makes it very, very difficult, again, to do this statically. The other broad class is called capabilities, and there's a few subtypes, and today we're going to talk about certificate capabilities. So same basic picture, you have a user, they want to access some resource, let's call this an auto-merge document, and the first thing you do is you make sure that this resource has a public key and a private key, and it can create a certificate to the user. Great thing about this now is if it receives that back, you don't have to check anything else. It issued it itself. And the request now, as long as you include your certificate in the request, it is self-contained and has all the required information. You don't have to go anywhere else, check anything else. It's all in one place and travels around with the request. Adding new people to the system, you create what's called a delegation. So we create a chain of certificates that that are signed cryptographically and point at these different users, these different agents in the system. And now when this artist goes to access this resource, they include the entire chain behind it. And nobody has to be online. Nobody has to route anything. It just goes directly, as long as you've included the certificates itself. Self-certifying. So unlike being a bouncer at a club, this is more like going to a movie theater. You have your ticket, you go in, they tear your ticket, and they say, yep, you're allowed into theater 3. And that's it. Often then this actually produces DAGs, but it can produce trees. And if we want to make a request like this, so from this one user all the way back in through this delegation chain, we don't have to sync the rest of this information. We only have to care about this one request. In fact, you don't have to sync any lists in the background because it's all self-contained. There are reasons why you might want to do caching, things like that for performance reasons. Again, we have 10 minutes. And because the information is flowing around based on resources, not particular applications, now as you're delegating, and these emoji are representing different things these users can do, you can always delegate if it's the same level of authority that you have or less. So if I have read and write, I can delegate to you both of those or just one of them, for example. So as we're delegating down, and we can fork and merge them back together, all of these things, these can now cross the app boundaries trivially, right? So I could have, let's say, a social media app, a spreadsheet, and a LLM, let's say. And they can all make use of the same underlying data. They can all update, and they can all tweak it to work for their particular use case in a way that's completely interoperable out of the box. We'll show how in 1 second, but all with zero coordination. So the raw mechanics of these chains, the first step is each certificate says what resource it's about. So in the case of a CRDT, you would say, hey, this is the public key identifier of that CRDT, which is even better than a UUID because nobody else can copy it for a different version of it, right? It has some origin points. We start from that specific resource, and we say, okay, I'm going to delegate to this particular user. And at every step in the chain, we check that the things that they're allowed to do, the things they can do, match up, so they're the same level or smaller, and that the from of the next step matches the to of the last step. So we can create now this self-certifying chain. And once we've seen this whole path, then we can generate out along the bottom who's allowed to do what for that delegation chain. Here's an actual UCAN with the crypto stripped out, so no signatures. The top left one is a delegation. The bottom right one is invoking that authority. And so we can say with the subject, so about this document, for an update to this CRDT, I'm going to restrict syntactically. So we don't need to know anything about the domain in the library. I'm going to restrict syntactically at this path with basically like a JQ syntax, that this field has to be greater than 42, and that the previous link on this one has to be exactly this hash. So you can only update off of this exact point in that CRDT. And then the invocation can be checked trivially against this, just directly using the library. We check that the to and from fields, the issuer and audience, and the subject all match up, that the proof chain of these delegations line up, and that all of the arguments match this syntactic checker, this little embedded predicate language that we have. One of the perspectives that capability systems in general have is that agents are abundant. They don't have to be just people. They can also be processes or your browser or any of these other things. In fact, it's slightly more honest because you're not delegating to a person, you're delegating to their user agents, right? And the idea is that you have very few human administrators with lots of power in such a system, but you'll have billions of throwaway single-purpose workers, and you can scope down as fine and as granularly as you need to, and they can't ever escape that. And so when you put something into a task or into a worker, you restrict down the absolute maximum that you think that they're going to need, which should be very constrained. And so if you have something like an LLM that may hallucinate a bunch of your intentions and delete all of your data and do all of these things, you just don't give it access to those things. You say, I want you to do these 3 exact things. I'm going to restrict you to do only those. This also gives us a very minimal surface area because we use this thing called principle of least authority, and it avoids any confusion about who is doing what. So if I delegate something to a worker or an application, and then if I ask a worker or an application to do something, or a service, and then it turns around and does another thing, whose authority is it using? Is it using mine? Is it using the services? And in an access control list world, this is often confusing. In fact, the default behavior is for it to use whoever I asked to do it. And there's been a number of very serious bugs over the years that use this to do privilege escalation. With this model, you have in the request, you know exactly what that request, never mind the user, that request is allowed to do. So you can completely eliminate this class of problem. You never run under ambient authority. and you just run with what you were handed. So to wrap up, basically, these give you a very simple programming model. If you have it, you can use it. It's a little bit like a file handle. In fact, you can even pass them around as arguments to functions. And so you can say, where do I want to upload this? Here's a UCAN to say upload to there. So if I want to switch which server I'm syncing to, and they're guarded by auth, I can just pass these around almost like you're passing a reference. This closely models the ground truth and, in fact, goes out of its way to model and get rid of any of the other underlying assumptions. We have a bunch of implementations of this. If you do an implementation in a new language, you too can have a cute logo made. So if you do one in, say, Python, drop us a line and we'll have one of those made for you. I'd hoped to have the 1.0 version of the spec and implementation out for today. Sadly, we didn't quite make it, so at any moment now. So there's one in TypeScript from another team, and I'm working on the Rust and Wasm one right now, and we have previous versions in TypeScript, Rust, Go, and Haskell, plus some other ones on top of it that do things like login and secure sessions. Thanks.